Hello everyone, I'm very glad to be here with you today again for another awesome video. In the beginning, I would like to give a special shout out to all our new subscribers. Thank you for joining our community and being part of our new journey. And also, please don't forget, if you find my videos helpful, entertaining and informative, please consider subscribing and help us grow and reach more people like you. Thank you again everyone, and thank you for waiting for my videos patiently. Without wasting time, let's start our class. We're still covering IP addresses. There are still some topics that we need to cover in IP addresses. So without wasting time, let's jump in. Today, the first thing I would like to cover is the subnet mask. What is subnet mask and why we are using it in with IP address and in networking. A subnet mask is used in networking to divide an IP address into two parts, network address and host address. As we know that we already discussed about network portion and also host portion IP addresses. At the same way, subnet mask identifies the network and the host portion of the IP address, and devices, when they're communicating, they understand based on the subnet mask that which portion of this is the subnet mask and which, the host address, and which one is the network address. The subnet mask is the format is the same. It is expressed in dotted decimal format. It means it is the same way we can represent it as 4 octets, and each octet is separated by a dot. Now, every class in IP address version 4, every class has a default subnet mask. For example, class A, the default subnet mask in class A is 255.0.0.0, where 255 represents the network octet, and the zeros represents the host octets or the host bits. So if we want to say bits, means we have 8 bits of network in class A and 24 bits of host address in class A. The same way I mentioned here that 2255 represents the network octet and zeros the host octets. Now, if we want to write this default subnet mask for class A in binary form, it will be something like this. The network bits are represented with ones, and the host bits are represented with zeros. And in class B, we have 2 octets of network address and 2 octets of host address. So the 2 octets of network address is 255.255.0.0, and in binary form we can represent it as 2 octets of ones and 2 octets of zeros. And in class C we have 3 octets of networks, 255, 255, 255, and 1 octet of hosts, so that we represent it with 0. And in binary form we represent it as 3 octets of ones and 1 octet of zeros to represent the host address. Anyway, I just want to mention that the binary form, why I mentioned it here, why I wrote it here, it's because when we are doing subnetting, we really need to know these binary form, because in subnetting this is very helpful in helping us to calculate or do the engineering in subnetting. It makes it easy for us to understand. So just remember that when we are writing the subnet mask in binary form, instead of 255 we represent with 1 and the zeros with 0. That's all it is. So if you remember, in the previous video I mentioned about converting decimal form to binary form. Today I'm doing this only for the sake of next video, because we're going to talk and we're going to do subnetting. That's a very important topic in IP addresses. So that's why I'm trying my best to make it very simple and easy. But if you did not understand, it's okay. We are still gonna cover this topic in the next video, which is subnetting. But before that, let's see how we can convert a decimal form of an IP address to binary. So I divide it in some steps, which is like maximum 4 steps. It's very easy to do it, but it doesn't need any like magic or anything. It's very simple calculation. So the first step is that we need to separate each octet. That means the IP address, we separate them by each octet. and then we divide each octet repeatedly and noting the remainders until we reach 0. And then we combine the binary octets from bottom to top, means from reverse way, and then pad with leading 0 if necessary. So all these steps may look like something difficult, but when we do it in the next slide, it's very simple and easy. So let's look at the practical, the way I did it, and then we can get a clear idea of how it works. So here we go. So we have an IP address of 192.168.1.1. So by now we should know that this is an IP class C, and this is a decimal form. We want to convert it into binary form. So as we mentioned in the previous slide, we need to first divide or separate each octet. So what I did here, 192.168.1.1, and then we divide each octet separately until we reach 0. And if you see here in this second row here, we have 0. That means we divided 192 until I reached 0, and then I stopped. So let's see how it works. So if I divide 192 divide by 2, I get 96, and the remainder is 0 because it's a perfect, there is no remainder. And then if I divide 96 by 2, we get 48, and the remainder is 0. And then if I divide 48 by 2, it is 24, and then the remainder is 0. And if I divide 24 by 2, I get 12, and the remainder is 0. And if I divide 12 by 2, I get 6, and the remainder is 0. And if I divide 6 by 2, I get 3, and the remainder is 0. Now, if I divide 3 by 2, I get 1, and the remainder is 1, because it's not going to be perfectly divided. So it will be a remainder of 1. Now if I divide 1 by 2, that will be 0 because there is nothing is going to left, so the remainder is 1. Now the third step was to write from bottom to top, means from reverse way. So we're going to write it 1 1 and then 0 0 0 0. This is what we did. In the first octet 192, we represent it as 1 1 0 0 0 0, and that is it. Now this is the binary form of 192, and we do the same operation on 168, and we get the result as 1 0 1 0 1 0 0 0, and here we go. I wrote it the same as it is. Now here on 1, so we have another, the third octet is 1, so if we divide 1 by 2, it is 0, and the remainder is 1. So here we have only one bit, and we don't have anything else to divide, so what we do, we add the leading zeros. This is called padding with leading zeros. So we add 7 zeros in front of 1 to make 8 bits, or to complete the 8 bits. So now what we do, we add 7 zeros, 1 2 3 4 5 6 7, and then 1. So this is what I did, and we do the same thing with this one, and then we combine them and separate them with a dot. So the same, I wrote it again here, 1 1 0 0 0 for 192, and then for 168 1 0 1 0 1 0 0 0, and then dot, and then 0 0 0 0 0 0 0 1, again dot, 0 0 0 0 1. This is the binary form. That is simple as it is. Remember, this is very important for subnetting. So if you remember this, and if you are able to do this, this makes it very easy for you to do subnetting. Perfect. Now let's see what is network ID. And first video we mentioned about broadcast ID and the network ID. So I thought it's important to know what exactly the network ID is, and network ID is, and how we can represent it. So the network ID essentially tells devices on the same network that they are part of the same logical group. Devices with the same network ID can communicate directly. I will do a small lab on this one to show you what exactly this means. It basically means that when we have the same network ID, the devices in the same network can communicate directly without needing a router. So they can directly communicate using a switch, or even without a switch. If you use a crossover cable to connect one PC to another PC, they can communicate as long as you have assigned IP addresses to the devices. They can communicate. Or if you use a switch using a straight cable, connect all the devices to the switch, use the same network, they will still be able to communicate. So it's very easy. How we can represent the network ID, it's very easy. So to represent the network ID, instead of the host octet, we always put 0. So for example, if I have, this is a class C, by the way, class C IP address. If I have 192.168.1.1, so we know in class C we have 3 octets of network and 1 octet of host. So instead of this host octet, I put 0. And this is the network ID of this class. Now, if I advertise this one, the devices understand that all the IP addresses, the host addresses in this group, can communicate with each other because they are in the same network ID. And the same as in the previous slide, we discussed about subnet mask code. So this is the default subnet mask for class C, 255.255.255.0. Perfect. And we also mentioned the broadcast ID. What is broadcast ID? It's very important to know, because when you do networking, you need to know these things. What is network ID? What is broadcast ID? A multi-point connection in IP networks that automatically reaches all nodes in the network without knowing the recipient's address. For this purpose, a fixed reserved broadcast address exists in each network or subnet. I will give a very easy example to make you understand. When you have a network and you have, let's say, many routers connected with each other directly or indirectly, if they have a direct physical connection, or if they're connected through another router, when you establish the connection, they send a package. That package called hello package. Hello package basically means that they tell each other that this is me, I am here, and this is my network, this is my neighbor, this is all my information. That's called hello package. And that hello package is being sent using the broadcast ID, because the router, they don't care to know about your address, they don't care to know about the other devices' IP addresses. They use the broadcast ID to send that hello package to everyone. So it basically means that for every class of IP address, we have a broadcast ID, and that broadcast ID is used to send or to say hello to each other. The networks or the routers, they're using that to send or say hello to each other, and also in communication when they don't need to know the address of each other. So let's see what's the broadcast ID in class A. So this is a class A. By the way, this is the network ID 10.0.0.0, and the broadcast ID in a state of the host portion, which is 0, we put 255.255.255. So the host portion or the host octet represents with 255, that changes to broadcast ID. So for class A, the broadcast ID is 10.255.255.255. Now for class B, this is, by the way, the network ID 172.16.0.0, and the broadcast ID is 172.16.255.255.255. And for class C, because we have only one octet or one byte of host address, so we represent it with 192.168.1.255. And that's it. So you just need to remember the broadcast ID, and you need to know why they are used. That's all. Perfect. So this was it. This was for today's video, and the next video we're gonna discuss, and we're gonna do subnetting, which is very important. Stay tuned and wait for the next video, which is it would be very interesting. Right now I'm going to do a small lab on showing you what's the network ID and how they work and how they can communicate if they're in the same network. I will make it very simple and easy. I will use packet tracer. Okay, perfect. Here I am with the packet tracer. So I didn't start a topology. I just wanted to make the topology with you together with everyone. So at least if you don't know how to use the packet tracer, or where you can find these devices, we can do it together. I will put the link for packet tracer on the video, the description of the video. It's very easy to download and install it. If you want to download and install it on your computer, it's very easy and simple. Click on the link, create an account, download the packet tracer and install it. And then once you installed it, this is what you see when you open it. You can see it like this. On the left side, you have all the networking devices. So the first one is routers. There are different routers. Each one is different. Then we will explain these in details. But on this lab, we don't need to use routers. We only need to use switch. So when you click on the networking devices, we can click on the switch, and then we get one switch. The first one is the 2960, which is, I think, good enough. It has 24 ports, so we can use this one. And then on the second, it says end devices, mean the user devices, so we can click on that, and then we have different devices. We will do a lot of labs using all these devices. We have VoIP phones, we have servers, we have tablets, smartphones, like all kind of devices. We will do the labs for everything. Everything we will do, cover all of these. So for now, we only need a switch and PCs for this lab to just show you how, if the networks are different, how they communicate, or they will be able to communicate or no. So here is the connection. Here is basically the cable type. So the first one is automatic. If you don't know which cable to use, you can use the automatic cable, and this automatically selects based on the type of the device. They select the cable for you. And if you know which cable to use, and if you know the type of cables, then it is easy. I will definitely cover this cables and type of cables one day to basically explain all the cables, what cables, when we can use it and when we need to use, so it makes it easy for you. For now, we need a straight cable because these are different devices. When there are different devices, we can use straight cable. So this is the straight cable, so I can use this one, and I can use fast Ethernet port 01 to the port 0. So if you use the automatic, you don't need to pick up. It will automatically select the next available port. So that's the 02. And then because you don't need to pick up. Perfect. Now, what we need to do, we need to pick up a network, an IP address. Basically, for all these devices, first we need to decide which class of IP address we use. If you're working in a company or organization, depending on the number of users you have, depending on the networks you need, you can use different class of IP addresses. We already covered that, so you can then decide based on the requirement. But for now, I'm just using the class C, and I'm going to use the 192.168.1.0. Now, we know that 1.0, this is the network ID. This is not an IP address. This is the network, because instead of the host octet, I use 0, so this is the network ID for class C. Now, for all these devices, I can use different IP address. So, for example, for this IP address, I can use 192.168.1. let's say 2, and for this PC, I can use 192.168.1.3. and for this one, I can use 192.168.1.4. Now, this is just, we are making it so you can, I'm writing here so you understand exactly what IP address I'm using. Now I'm going to configure this IP addresses in the PC. So to do that, we double click on the PC, and then we go to desktop. And the desktop, we go to configuration. The packet tracer is very easy because it's like a graphic interface mode, so you can easily see what you're doing. And then you click on IP configuration. I'm using a static because I don't want to use a server. Right now, it makes the video very lengthy. If I use that, we can do it, not difficult, but it makes it very lengthy. So what we do, we assign a static IP addresses manual. So for this one, I'm using 192.168.1.2, and it automatically picks up the subnet mask because we know the computer knows that this is a IP class C. So for IP class C, it automatically picks up the 255.255.255.0. And default gateway, so if we use a router on this network, I don't need, because this router is only internal and it doesn't go outside, and I don't have a router to assign a default gateway. And but if you want to, in the future, if you want to use and you want to reserve an IP address for that, so that's why I didn't use the 1.1. I reserve for my default gateway. I can use it, although I don't need it on this specific lab. I don't need that. Communications doesn't need default gateway at all, because this is internal, so we don't need, but I'm just writing it, so that's fine. And there is no option to save or anything. As long as you close it, it is saved. And if you want to see it, you can just put the cursor on the device and you can see the IP address is written there, 192.168.1.2, and /24 is basically the CIDR notation. CIDR notation means that it's telling you that this specific class of IP has 3 octets of network, which is 8 bits. 8 plus 8 plus 8 is 24. And now we go to the second PC4, and we configure the IP address, and the same 192.168.1.3, and subnet mask automatically picks up 192.168.1.1 and just close it. And we do the same here. Sorry, not dial up. We go to IP configuration and we do 192.168.1.4 and 192.168.1.1 and just close it. And so as soon as you close it, the IP addresses of all the devices are already there, assigned. So what we need to do, we can either ping easily. So again, we can click on the PC, any PC, and then we go to command prompt here. And first, if you want to see, this is like real time in your computer at home. If you open the command prompt, CMD, if you type on the Windows search CMD, and then if you open the command prompt, and if you type on ipconfig, it shows the IP address of your computer with default gateway and all the information. So, and now I want to ping this is 1.2, and I want to ping 1.4, 192.168.1.4. And you see I'm getting the reply, means there is communication, and it's perfectly fine because they're in the same network, and that is 192.168.1.0. Now let's say I pinged 1.4. Let's say if the 1.4 is this one, so if this PC5, if I change this IP address, if I change it to, let's say, 2.4, and when I change the IP address, I need to change the default gateway as well. So if I make this 2.1 and close it, now we see PC5, it is 2.4. Now let's see whether PC3 can communicate with PC5 or no. So again, we go to command prompt, and again, we already have the command typed already. So what we need to do is we need to just use the up arrow key to bring that command that we already used. So first of all, we ping the 1.4, and we see that it's not reachable because this IP address doesn't exist on the network. We changed that, and that we didn't assign this IP address on another device, so it's not there, and computer cannot find it. So let's ping 2.4. And if you see here, the 2.4 doesn't reply, although 2.4 is that 2.4 exists. 2.4 is the PC5, but it doesn't reply. Why? Because we changed the network octet, which is from 1 to 2. Now this PC is on a different network. This is on network 2.0 because we changed the IP address. Remember, in class C we have 3 octets of network. If you change any one of them, devices in the same network will not be able to communicate. Now if I want to make this computer to communicate with this network, I need to have a router, which is not necessary in this lab, so I don't do it. Now if I change this back to 1.4 and change this one to 1.1, they should be able to communicate. Now go back to PC3 and again ping, sorry, not 2.4 because 2.4 doesn't exist, so we ping 1.4, and you see the ping started and it's working perfectly fine. Now if I ping 1.3, the 1.3 also working. So it's basically, this lab was to understand the same network. What does network means, and what's the network ID means, and how the computers understand that they're in the same network, and when they're in the same network, they can communicate directly with each other without using a router or anything. Now, this was the real time. If we want to do a simulation how the packet travels, so we can click on simulation on the right side, and then we can edit the package, because we don't want to send a very heavy package. We can only send a ICMP package, so we can unmark these all other packages as on the edit here, edit filter, and you close this one. And now I don't want constant delay, I just unmark this as well. So now you get a package from the top here, you get a package and then put it on one PC and then on another PC. Now you just click on the play button, you see how it goes from the PC3 to the switch, and from the switch it should go back, it should go to the PC5, and PC5 should send the acknowledgement to the switch and switch back to the PC3. Yeah, that is perfect. And now you see it says successful here, and there is a check mark. That means that some communication was successful. Okay, guys, that's all. This was for today. With this, I wish you all a very great time with your families. Stay safe and healthy. Thank you again. Please don't forget to like, subscribe, and share.